In the spring of 1997, sick fish began showing up in the pound nets of watermen working along the Pocomoke River. And soon after, some of those same watermen began showing up in doctors' offices. In these pound nets, floating among the sick fish, was a microbe called Pfiesteria piscicida, first identified in the wild by a North Carolina scientist named JoAnn Burkholder. She claimed this one-celled organism could sometimes release a toxin in the presence of fish, and that toxin could make people sick. Pfiesteria could also change shape, shifting through 24 life cycle stages, from tiny zoospores all the way to large amoeba forms. The search for more answers about this organism has led to conflicting, even contradictory findings, kicking off complicated debates among marine scientists. When Wayne Litaker investigated Pfiesteria, he found a very simple life cycle with no amoeba forms at all. He used sophisticated molecular RNA probes as well as computer-controlled photography.
So you actually have the computer turn the microscope on every so often, turn the lights on, take a picture, turn it off, and then you put it all together in a movie and you can actually follow what's happening through time. We never saw any transformations. We saw a normal 7-stage dinoflagellate life cycle. So we didn't see any of those transformations whatsoever.
Other researchers contradicted Burkholder's claim that Pfiesteria used a toxin to kill fish. At the Virginia Institute of Marine Science, Wolfgang Vogelbein announced evidence that Pfiesteria kills fish by directly feeding on them, not by releasing a toxin.
Okay, what you're seeing here is the tail fin of an anesthetized fish. These fish and these dinoflagellates are directly attacking the fish and feeding on the skin. It's that simple.
Vogelbein put a filter between his hungry Pfiesteria and his tiny test fish, a filter that would keep any Pfiesteria out but let any toxin pass through. A simple experiment with repeatable results. None of his fish died.
We can actually see what's happening, and we're finding out that there isn't an exotoxin here, at least not in our cultures.
Fish were not dying from Pfiesteria toxin, but from Pfiesteria feeding.
This happens. You've seen it today. We've shown it to you. Firsthand, you've seen it. It happens. This is how fish die in our cultures. Others say toxins kill their fish. Fine. Let's do a comparative study. Let's get to the bottom of it.
Toxic Pfiesteria is not on trial here. Toxic Pfiesteria exists. There's no question. It's been cross-confirmed in multiple laboratories.
Andrew Gordon runs one of the laboratories where a Pfiesteria-connected toxin is killing fish. His technique, run water from a toxic culture through a filter, removing all the Pfiesteria cells, then test this filtered Pfiesteria-free water on small fish.
I have no doubt that in these systems, in the presence of Pfiesteria, that there is a soluble toxin produced. I mean, we've seen it. I've had undergraduates do the experiment. They've seen it. They're all over the country now. And they're believers because they've done the experiment themselves. It's a very simple experiment to do.
A simple experiment with repeatable results. In most of his experiments, all of his fish died.
The toxin that's produced is Pfiesteria associated. You never see it in the absence of Pfiesteria, and you see it in the presence of Pfiesteria. So that's pretty clear.
What is not so clear so far from all these studies in the laboratory is how much harm these toxins can cause in our rivers, either to fish or to people.
We have a long ways to go. We just don't understand what turns on and off toxin production in these creatures. I wouldn't be surprised if the so-called non-toxic or non-inducible strains of Pfiesteria make toxin, but just can't somehow turn it on or activate it. And we'll be finding that out, I think, in the next couple of years.
By the time Pfiesteria blooms again in the Chesapeake, scientists may have more answers to some of these contentious questions.